We are live. There, Scott.
Okay.
Hello.
The first week of the year, another episode of Ask Us Anything. Here to answer your questions. Just start typing them. And while you're typing, just something came up to my mind. If anybody wants to sponsor this show as a company, that would be great because I'm going to start collecting money to buy Scott a microphone. It hurts my ears to listen to him. I don't know how you guys do it, or girls.
You know, what can you do? The microphone won't help with that.
It will help a bit. It will not make you pleasant to listen to, but pleasant, more pleasant, less unpleasant. Let's put it that
Exactly.
way, right? Okay, so we have, like always, we have questions from before. Actually, for some reason, I couldn't collect comments from the last video, but I have some last stream, but I have some questions from before, so we're going to combine them with the questions you're typing right now, left and right. So let's go with the first one. No criteria. I haven't read the questions even, by the way. So no criteria here. Anything goes. The first one is, any tips for operator developers? More specifically, their operator is managing external resources and mapping them to Kubernetes objects. And my short answer is, you literally writing operator with Go, I think that's amazing. I think that you should do it. But mostly if you want to do something unique. So let's say that you are, let's say, Oracle, right? And you want to create operator for Oracle, right? You should create operator, you should write it in Go and what's not. Now, if you want an operator that manages, as it says here, external resources, I think you should go with existing solutions and save yourself from trouble writing Go or whichever language you want. There is Crossplane. Doesn't have to be Crossplane. You can, let's say, if you're in AWS, that would be CDKs, right? And then you can combine it with Crow. So don't think about. I'm not answering this because Crossplane is a solution.
More ACK. It would be ACK, not CDKs, right? It would be the AWS controllers for Kubernetes or ASO in Azure, or right, exactly.
Exactly. But don't try to kind of write it yourself from scratch for something that already exists.
Yeah.
Write operators for unique cases, right? Something very special.
Write an operator when you absolutely need to, and use tools when you can. And they suffice what you do, because it's just going to be much easier to maintain over time. There
we go. We're in agreement so far. Question live. GitHub repo. I don't know what the question is. So Sri Vishnu, whatever the name is, if you can clarify, we'll do our best to answer. And from Ari, we are live. Thank you for enjoying the series. Would you consider making this a podcast series in audio format on Spotify or the like? I don't know. So if more people say that they would like us to publish this as audio, I'm open to it. I'm not sure whether the format is to listen to. I mean, why not? Yes, I'll figure it out. We'll figure it out somehow.
Exactly.
Okay, now the question from Fermion. Welcome, guys and girls. Why is it not considered good practice to run databases on Docker or K8s? You want to go first?
Sure. Not running on Docker, completely agree with, not good practice. Not running on Kubernetes, I will completely disagree with. I think it's a very good practice to run it on Kubernetes databases, as long as you're using the appropriate operators in order to do that and not just going with a stateful set and, doing it on your own. Use Cloud Native Postgres, use, Crunchy, use Zalando Postgres, use MySQL operators, whatever you want, whichever databases is, find the right database operator. If it's the MongoDB operator, great. It makes a lot of sense to run on Kubernetes if you use an operator that is built well and that supports Kubernetes and those features well. On Docker, I agree, because you need orchestration for these things. Now, what I will say, though, is when the question comes of do you run a database in Kubernetes or not, if you're on-premise, I see almost no use case of not running it in Kubernetes if your application is in Kubernetes, because you're anyways managing it on your own. If it's in the cloud, it comes down to what your competency is in managing the databases. And are you willing to pay the premium for AWS to manage the database for you in RDS, and then maybe create it through Kubernetes using ACK, using Crossplane, using some tool like that, but have it run as RDS, and then what you have to manage, what you need to support is lower, right? So in the cloud, you have that, ability to come and say, I would rather pay more and be responsible for less. On-premise in your own data center, you own everything and you're in charge of everything. So at that point, I don't really see a major reason to not run it in Kubernetes unless it's some monolithic database that's petabytes of data and things like that. And then, okay, fine, get bare metal servers.
I feel that the saying that databases are not good for Kubernetes, I think that comes, and I feel that you hinted at it. I think it comes from the past when we did not have proper database operators. We did not have something like CMPG. A random person created a container image and then spent 7 minutes defining a stateful set and said, there you go, database in Kubernetes. And then somebody else used it and said, no, databases should not run on Kubernetes, right? But to me, that's similar to kind of, hey, we had many other cases, this should not run in Kubernetes until we got to the point that actually we figured out what are the correct ways to do it. And exactly. Kubernetes core resource, I would go even as far as to say that we are either right now, or we are going towards the part that nothing should be running Kubernetes with Kubernetes core components, right? You need to bring proper controllers to run something, unless that something is very simple. The only other thing that I would say that even though I haven't been using Docker for anything serious for a long time, I'm not necessarily against running something in Docker, including database. If you're talking about small shop, kind of, hey, I have 2 servers in total. This is a hobby business, and I don't want to figure out Kubernetes, kind of. Okay, or I have 1 server. Yeah, run it as Docker. There's nothing wrong with it, as long as you don't go beyond 2 servers, kind of like.
Exactly. Yeah.
Okay, let's see. From before, the infra-related workloads like Velero, Keycloak, etc. is nice to install through OpenTofu or Argo. I would say that the latter is correct. I'm very much against using OpenTofu to manage Kubernetes resources, not because OpenTofu is a bad tool. It's a great tool. Terraform is great. But those tools are not designed to manage Kubernetes resources. You're better off running it as Helm or Customize or anything you want. Just there is, I feel that that's a level of abstraction that doesn't bring anything.
Yeah,
to the mix.
I agree. I think that what I do like to do is like, whether it's Terraform, OpenTofu, whatever, is you can use the infra as code to do the initial deployment of Argo CD in that initial application that then ends up managing Argo, right? Like, so I do believe that like that initial install of the application of Velero or the Argo CD and the Argo CD application that installs Velero, Keycloak, whatever, can be from OpenTofu, but what ends up reconciling or managing day 2 those components has to be Argo CD, or should not be Argo CD to be more exact, and should be Flux, but that's a whole nother conversation.
Okay.
It should be a GitOps tool.
It should be what?
It should be a GitOps tool. Let's put it at that, whether Argo or Flux.
Yes, and even if you say, and I will judge you for that you're not using GitOps, I would still rather do, imagine that GitOps doesn't exist. I would still rather do Helm install Keycloak on existing clusters. So I completely agree. If you're creating cluster and you want that cluster to have something by default, like Argo CD, great, right? Use whatever you're using to create that cluster. But once you have it, and even if there is not such a thing as GitOps, I would still prefer Helm install. It's more native. It understands Kubernetes, really.
Oh, but what about using the Helm Terraform provider?
What is a Helm Terraform provider?
There's the Terraform provider for Helm. Like that you can just give it a Helm release and it will install a Helm release.
Okay.
Like the Crossplane Helm provider, right? Same thing. It can install a Helm chart. It installs a release. So it actually just does Helm install basically, right? Which is better than the Kubernetes provider because.
True, absolutely true. I still somehow, I don't know, maybe I'm too biased then. I still kind of, if you have something in that cluster that is going to stay the same version for a very, very long time or forever, it's fine. But I think that we should be updating it by changing Helm values file and just Helm install. And I'm skipping now GitOps. You should use GitOps. But if you don't, I still feel that it makes more sense Helm upgrade than not. But hey,
exactly.
Who knows? If I set request only for CPU without limit, it's best practice, or there is another solution that are better for it. I'm not sure another solution for what though, but I guess that the question is, should we be setting? There are people who are very vocal about not setting limits on CPU because. There we go. That's one of them. Explain yourself, young man.
There is absolutely zero logic in setting a limit on CPU because you aren't going to get out of memory killed. You're not going to get anything like that. You should not be starving the CPU performance of any container. You need to set requests and you must set limits for memory.
Exactly.
But CPU, the worst you're going to get is a bit more ready time, so you're going to get worse performance. The worst you're going to get with memory is out-of-memory kills of applications. So therefore, memory, you should set it. CPU, you should not, and let the fair scheduler of Linux or the CPU scheduler of Windows, which is a bit less fair, but the Windows scheduler, if you're running Kubernetes with Windows nodes, let that handle the scheduling through cgoops v2.
Yeah, exactly. I mean, I think that's the key difference, that the way how memory works in CPU is very different, right? Simply, applications are not killed when they need more CPU. They're just slower or something like that. And they are killed when they need more memory.
Right. The other thing I would say is that no one that I have met in my life has actually known how to set requests or limits correctly. So why not just set one less thing incorrectly? You're going to set requests and limits wrong because no one can figure out what they should be. So you might as well just set 3 things wrong instead of being wrong with 4 things.
No, but it's also that, memory usage, it's much easier to, if I would have to place a bet, whether memory or CPU is set correctly. Let's say that only one of those two is set correctly and you don't know which one. My bets would always be in memory because memory is so much easier to observe, right? If you go to Prometheus, you see memory usage much more clearly. And to me, that's closer to science than CPU.
Yes, however, what we also see is that people set memory limits much higher because they're scared of out-of-memory limits. They're not scared of the bit of a performance degradation. So the requests will be closer to correct than CPU requests, but the limits of memory are going to be like 5 times what they actually should be because, I don't want to get an out-of-memory kill. And then what ends up happening is you only figure out 3 months later that you have a memory leak.
True.
Because
but
it's
that also depends.
slowly grows.
No, if you exclude the cases where, and that they happen to be majority, where actually memory only increases in application. If application is done right and memory goes both up and both down, which I'm not saying that is always the case, most of the time it's not, then actually if you're scaling horizontally your application, then the chances of memory limit are going drastically down, right? Because your memory is going up. You say scale when it reaches 80%. Then the second replica comes in and they both go down instead of keep going up, right?
Right. However, when you look at most HPAs that exist out of there, it's based off of CPU. Like most HPAs that you see out in like examples are all like, okay, when CPU's at 80%, then scale. It's like, why? But anyway. Exactly.
Okay, this is a question from before, that infra guy. Since we are moving towards more and more platform engineering, is it okay we develop cloud abstractions by extending Kubernetes API? This means creating CRDs and custom operators. And there's probably more of it, and then I did not copy it all. But we get the gist. And I will have a short answer, and then Scott can talk for half an hour, and the short answer is absolutely 100% yes. Kubernetes is supposed to be extended. The only question I think we should have is whether you should be extending Kubernetes with CRDs you created or with third-party CRDs. And there is zero doubt that you should be extended with third-party, because the moment you install Argo CD, you might not know, but you extended it with a CRD and a controller. Yes. Whether you like it or not. Every single cluster I've seen has at least one CRD and a controller there, whether you know it or not. Now, whether you should create CRDs, that's a tougher one to answer, because especially for smaller shops, you might not need it, right? Let's say that you want easier way to manage applications, and maybe Knative is all you need. Maybe there is no need for you to create your CRDs.
Exactly. I do believe 100% that Kubernetes needs to be extended. No question about that. Writing your own operators, only if you absolutely have to, and in which case it's a great solution, but you should be using tools that make that easier. Crossplane, Crow, Kubevela, anything like that type. Or if you don't even need that, just ACK, ASO, from like the AWS controllers for Kubernetes or Azure Service Operator. Use something that talks to the cloud APIs and do that. And then you can create compositions with Crossplane or anything to create your own wrappers around that. It's a great way of doing it. But again, writing your own operator comes down to the question of, is this the core competency of my company that legitimizes me spending the time and effort of maintaining a full operator? The amount of work it takes to maintain a composition in Crossplane is much lower than what it takes to maintain a Go code base of a Kubernetes operator that you have to keep updating to keep up to date with the dependencies of Kubernetes. So figure out what the least path of resistance is.
Especially if that CRD is doing something that potentially changes over time, right? If you create your own controller CRD to manage something in, let's say, AWS, and their API changes, you need to put in work for no good reason. But yes, use CRDs. What are your recommendations for Egress gateway configurations? And I don't have any recommendation beyond whatever you're already using for as a service mesh.
So specifically in the on-premise world, I know that Victor believes in Cilium. It's a great project. eBPF is cool. I'm a big fan of Antria specifically as a CNI. And Antria has an egress feature that's actually really awesome, like at the CNI level itself, that can go and do either through BGP or just layer 2. When you're on premise, it has a lot of real strong capabilities, because it can say like any pod with these labels goes out with a specific IP. Any pods and namespaces with this label go out with this IP. It's something that in the cloud we don't really think about that much, but on premise you have to think about, especially in like more legacy or enterprise companies, where a lot of times you're talking to a database and they want to open up IP to IP in the external firewall. It's like, I need to be able to set up a specific egress IP that I'm going to go out with. I have to be able to do these more advanced egress features, and that's where tools like Antria really offer a lot more flexibility than anything else. But in general, I would say as much as you can deal with egress as little as possible, in terms of just use what is there, use Kubernetes network policies as your firewall there. Do that. If you need to, use what the cloud providers provide, use what a service mesh provides. If you're using service mesh, I don't think that in most cases it is a big enough issue that demands bringing in service mesh if you don't need service mesh for other reasons. That's a big thing to take on just for egress. CNIs, a lot of them have that functionality as well, and I would recommend looking at that one.
There we go. From Jason now. What are your thoughts on how to manage late binding data or data that comes back from cloud provider when using GitOps? And the only thing that comes to my mind is write it to the resource. I don't know what else can be done, which is, I mean, at least that's what we do in Crossplane. It's not ideal because, especially in case of disaster recovery, but then I'm not sure what would be a better approach than writing.
Again, I think
the annoyance is, I don't know how Flux handles it, but the annoyance is that you may need to create rules in Argo CD, if that's what you're using, to ignore those fields unless they are like annotations or labels. Labels and annotations statuses are ignored by default, but I'm not sure about if you write something to spec that you might need to set as special rule to ignore it.
Exactly.
It's the same with Flux as well, right?
Yeah, you have to set rules that tell it what to ignore and not. Unless it's server-side apply, which you can do with the alpha field in Crossplane to have it do server-side apply, and then if it does server-side apply, then it works better, and you don't need to set that, right? Because there's all the stuff around managed fields there when you do server-side apply. But in general, yeah, there's no real good solution around this. Unfortunately, the best is to write it to the resource and have a Kubernetes backup solution in place that's backing up the resources continuously, so that then when a disaster happens, if it does, you go and restore and then bring back GitOps to manage it. But you restore with that, late binding data at the beginning. Okay.
From David, this is from before now again, back and forth. Do either of you utilize FaaS, or is this the thing of the past? And it's mentioning here Knative. Knative, now I have a feeling, I'm not sure whether you have any data, Scott, that to me, I think that Knative is awesome. It's almost certainly the best solution for self-managed serverless or FaaS or whatever one wants to call it. I'm not sure that it picked up enough. I'm not sure that I see it as widely used as I hoped for, to be honest.
Unfortunately, it is widely installed, I would say. However, I think that it's widely used in the wrong way. It's widely used as part of enterprise platforms that include it within them from different vendors. As like an under the hood implementation detail, be that in OpenShift, or be that in Tanzu, or be that in any of these different solutions that exist out there. But my issue with that is that the second that it's something that's under the hood and it's an implementation detail, there are better autoscalers, than the default in Knative. There are better tools for routing traffic than those that are necessarily integrated with Knative. There are better solutions for rollouts than what Knative has, whether it's Argo rollouts or Flagger, right? Like the second that it's an implementation detail, I would never use Knative. Knative only makes sense if that's the right abstraction to give to my end users, at which point Knative is awesome, right? But Knative should not be hidden away, because if I'm hiding it away, I'll just hide away the best of breeds instead of hiding away, Knative in my mind. Because there's also a lot of dark magic that happens there, that debugging Knative can be a nightmare if it's hidden away behind other things. I'd rather just deal with deployments, rollouts, and Keda.
Okay, I agree with most of it. Not all, though. I do think that if you know what you're doing, I mean, first of all, if you don't know what you're doing, you shouldn't be using Knative. And if you know what you're doing, then yeah, there are just as good or better solutions for scaling and for many other things that Knative does. Except one thing, at least I don't know of many solutions, if any, that will queue the requests until application scales from 0 to something.
HTTP scaler of Keda. Add the add-on for HTTP scaling, and it has a queue proxy.
Okay, I did not know that. So it queues requests and then send a signal to scale up?
It'll scale down to 0. It has an HTTP queue. Basically, it goes to there, and then it'll send it to your app once the app is scaled up. It's still it's alpha or beta. It's still not 100% there. It still has some whatever challenges, but it's relatively working pretty well.
Because when that happens, or when I first of all I wasn't aware of it, to be clear.
Yeah.
But now that I am, I need to try it out. Second, then I completely changed my story. If KDE is doing that, then I'm failing to see the need for Knative. My answer changes now.
Knative is easier to maintain than maintaining Crossplane with a custom XRD to make it easy for someone to apply an application. So if all you need is an easy way for a developer to define an application, awesome, great. Right? And then Knative is stupid simple. It's easy. It's great. Use the func CLI, and then you get FaaS capabilities around that as well. Awesome, right? That's great. But the second that it is part of a larger platform, the second that you're actually doing more, people will outgrow Knative quickly, I think. I think Knative is a great entry point into Kubernetes. I think it's a great way to get onboarded quickly. I do not believe it is the best at anything, though, in the areas that it's covering. It does a good job in everything, but it doesn't do the best job. So,
but I'm not sure about part of what you said, because you said something like, "Hey, if you're a newbie, my words, not yours, but interpretation, Knative is great, right?" But that's true only until it fails at something.
Right.
Yeah.
But is it going to be any more difficult to debug than HPA, KDE, an Egress controller, or Istio, plus everything that you're going to need to anyways have there to get that same capability? The answer is I don't think it's any more complex. Right? It's not much more complex to debug Knative than it is to debug all of those capabilities from separate tools that you also have to stitch together and figure out, okay, now I need to learn Helm as well, because I need to package up all those resources into one thing. And I have to understand the relations, and did I get my selectors right? And there's so many other things that you have to deal with then, right?
I don't know. Because maybe it's only me, right? So let's say that as alternative, I set up KDE and deployment and few more things, right? I feel that they would be still easier to debug for a simple reason, because I go to that chart, and I'm using Helm as example, it applies to anything, and take a look and say, oh, okay, so this is what I have. I have KDE in there. In Knative, I have no idea what it is. I mean, I do, right? People who are using KDE do know. But forcing you to assemble it forces you to know what it is, in a way.
Yes. Right, again, it all comes down to, I think that, sometimes we also have to just, base off of the happy path sometimes as well, right? We can't deny the fact that there will be failures, but when there are failures, if you're a newbie to Kubernetes, you are going to suffer, whether it is Knative or whether it is just a deployment with a service of type load balancer. You will suffer, right? So...
Okay, let's see, what's next? Okay, this is an open question. Anything goes. What is your prediction for what's coming for cloud control planes in 2024? Now, control planes can be many things.
Are we just going to use the upbound definition of what a control plane? Excuse me, the crossplane.
No. I'm trying opposite. I'm trying to avoid upbound definition. That's why I said it can be anything, because control plane is used in many different contexts, right?
Exactly. I think that what is going to happen is that we will actually get a definition around some of these things. I think 2025 is not going to be a year of much, let's say, major milestones in this area. I think that, but it will be one of the most important milestones. I think that this year in the platform engineering space in general, it's a year that we're actually going to start to get much clearer definitions of what things are. what is the difference between a portal and a platform? I think like we're starting to have the industry understand portal does not equal platform, right? And we're starting to understand what is a portal, what is a platform, what is a control plane, what is any of these different terms, what is shift down, what is shift left, what is these terms are finally, because we've had enough exposure in the market of tools in this area, companies that have enough experience starting and failing at implementing platform engineering, and other ones starting and succeeding, that we have enough data to actually come and say, okay, what are these terms? That is an industry, once we can then define what a control plane is, and I can define what a platform is, and I can define these things, that is when the industry will be able to move forwards and actually, iterate on those control planes and make them better. But it's very hard right now because everyone takes it in a different direction. So you're actually not moving forwards. You're just moving, kilometers to the right and left.
Exactly. What I do think is that in 2025, which might be different words for what you said, or maybe no, is that there will be increased emphasis of using clusters, separating many clusters or servers that are workloads and clusters and servers that are used to control something. And now I'm not talking about Crossplane, just to be clear, only cluster API, Argo CD, whatever it is, right? Kind of this is the cluster that does
this is
something.
Cluster.
Huh?
Call it a management cluster or a shared
exactly.
services cluster. Yeah.
And if that's what Jason calls control planes, then nothing revolutionary. I agree with you, but kind of bigger differentiation, and probably will be in big part brought by platforms. Oh, if you have a portal, you realize that you need a platform. Platform should not be a workload cluster.
Right.
What's the best way to run Kubernetes on-prem, bare metal or hypervisor? And I will split it into two questions, Scott, just because I can guess where you're gonna contradict my answer.
Okay.
Clusters with a fixed number of nodes and clusters where nodes are going down to be used by other clusters.
Okay. So
Now,
I completely get that question, because that's one of the questions that we're always asked about, like cluster autoscaler and things like that on premise. Doesn't make sense on premise. Like, I've already bought the hardware, right? So that's a very good question as well, right? So when it comes to Kubernetes in an on-prem environment, my answer is that in 90% of cases, it's better to run on hypervisors. There are edge cases where it makes sense to run on bare metal. When you need to mount in specific hardware devices directly in because you need the best performance and you need a specific NVMe pass-through device into the pod so that your specific database can talk to, okay, fine. In that case, just run on bare metal, much easier. Like, don't deal with the, overhead of a virtualization level. Virtualization, though, gives me huge benefits. And how do I know that, yes, there is a performance degradation depending on the hypervisor you're using, probably anywhere between 15 to 30% degradation over what you would get on bare metal for, around the same thing, right? In terms of, just in general. But why would I still run on hypervisors? Over 90% of the nodes running in EKS, AKS, and GKE as of like 2 years ago when I looked into this were all VM based, even though in AWS, Azure, and Google, it is as easy to create a bare metal instance as it is to create a virtual instance. That means that 99% of the clusters in the world are running on virtualization. So if it's good enough for 99% of the world, it should be good enough for you. The benefits I get when running on a hypervisor is my ability to like vMotion in vSphere or live migrate in like Rev and things like that, or Red Hat OpenShift virtualization or things like that, where you can move VMs over with their pods to another, host, do your maintenance on the hardware without ever impacting the workloads, right? Like, there's a lot of benefits that you get around this. The ability to spin up a new node real quickly because you have templates, right? Be that a OVF or VHD or whatever different format, or QCOW2, depending on which hypervisor you're using. it's much quicker to deploy a VM than to reprovision a bare metal server.
Man, I feel that the comparison with, I almost started believing you until you included public cloud into the story, man. The reasons why vast majority of VMs in public cloud are in hypervisors is because public clouds are extremely dynamic, right? And I'm asking for servers, and I want to ask for server with this size, right? That size, and so on and so forth. But
right.
On-prem is not.
Hold on. We'll get to the dynamic nature in a second. But what I'm saying is, but the idea of the cloud is to prove that performance issues, the 15% degradation or whatever it is that you'll get in performance, let's say between virtualization and bare metal, doesn't affect 99% of people in the world that still decide that we're going to run Kubernetes on virtualization. Meaning that the performance issue should not be the calculation here of the virtualization versus bare metal, because the world has said virtualization is perfectly good for Kubernetes, right?
That's true.
Right? And then if it was an issue in the cloud, we would see everyone creating it on bare metal instances, right? If it actually was an issue. But it isn't de facto, right? Because again, most applications running on Kubernetes are front-end applications, they're not, heavy processing, whatever. Machine learning applications, although we're starting to see more and more of that. But even those in the clouds are running on VMs with NVIDIA GPUs. What I will say about your question on, Victor, on, auto scaling, right? Do I do auto scaling? Do I not do auto scaling, which falls into this picture? Obviously, auto scaling much easier on hypervisors than it is on bare metal. On hypervisors, I have the ability of growing the ratio of vCPUs to physical CPUs. So yes, I'll get worse performance, but I can get more nodes, right? I can get more virtual hardware versus in bare metal. I have what I have, and I don't have any more than that, right? I can't, play around with things. I can't, kind of play with the system. So in the hypervisor world, auto scaling is a feature that is great. Why is it great? Because I would love to be at a 1-to-1 ratio of vCPU to CPU to get the best performance possible on a day-to-day basis. However, most organizations run anywhere between a 2-to-1 and a 4-to-1 ratio of vCPU to CPU in, virtualized environments. At which case, if you design to be at 1-to-1 and you do that scale in, scale out, even if no one else is going to use those resources at the same time, what you're going to get is better performance at specific times, but still adequate performance at the other times when you need them more. But if the node is there, it's using CPU. So why do that? You could also come and mention all the green elements of it, of being, ecological and very important elements there, both from a, real perspective, as well as many regulations are requiring this stuff now. So the less VMs you have running, the better, because less power consumption, and so on and so forth. I don't really see much benefit to bare metal. If you are using bare metal, use Cluster API to work with Canonical MAS, to work with Equinix Metal 3, to work with Tinkerbell, to work with any of the bare metal providers that you set up, basically, that manage them, that do all the IPMI weird stuff and manage that. Cloud Stack, do that. Don't manually do stuff, and don't do like a cube spray or something like that, please. We're not in the 1990s anymore. There are better ways of doing it. It's called Cluster API. Best way to run Kubernetes on-prem, again, as I mentioned in a previous session, use a distribution from a vendor, whether it is an open source one or a production one. Do not do Kubernetes the hard way. Don't just kubeadm install, kubeadm init. No, use a distribution, be it Rancher, be it Tanzu, be it SpectreCloud, be it OpenShift, be it, I don't care what, use a distribution. It will make your life much easier, and use one as much as possible that follows standards, that uses Cluster API, that uses normal operating systems, that uses normal CNIs, that gives you what you actually want.
I'm still not convinced that on-prem fixed number of servers, a single cluster. So if you have 5 clusters, I understand completely, because You scale down something, you scale up some other. But fixed number of nodes, fixed number of clusters, or nodes dedicated to clusters, I still don't see the benefit of hypervisors. I do agree that the downsides are not sufficiently big, but I'm not sure that I see the benefits.
The quickness of bringing up a new node. Do you agree that upgrades?
No. But if you have fixed number of 10 servers, I have no possibility to bring up a new node.
But you do if it's virtualized.
No, because I have 10 servers and I'm using them to full capacity. Why wouldn't I?
Again, because as I mentioned, you can just have for a temporary period worse performance. You can still create another VM. It's not like requests in Kubernetes, and you can, but you don't set reservations of resources to a VM. They all think of a VM as a process, and you can have multiple processes that, get the fairness of the CPU sharing. So you could have a 4-to-1 ratio. You could have 4 virtual CPUs on a single physical CPU, and they'll just share it, right? They'll have their performance sharing.
But they will be sharing those pods. Will be sharing the CPU, even whether they are from 5 different virtual machines or 1 physical machine.
Yes, the benefit of it being in virtual machines that you shrink your blast radius. So when something happens on a node, it did not affect. Think of the fact that if I need 5 physical servers worth of pods, if I have that split up into 5 servers, or I have that split up into 50 servers with 10 virtual machines on each host, and one of my hosts, the operating system, there's a kernel panic. There's something that happens, a pod escapes, there's issues go wrong with nodes, the kubelet breaks. Did I just ruin a fifth of my cluster, or did I ruin, 2% of my cluster?
Fair enough. I give you that one.
And also think about the fact of immutable upgrades, right? You want immutable nodes. You want to, when you do an upgrade, again, the best would be spin up another cluster on the side, manage things over, right? And then you never upgrade a Kubernetes cluster. We don't live in the utopian world that, we would like to. We upgrade Kubernetes clusters. If you're on bare metal, it is almost impossible to do side-by-side upgrades.
No, there are distributions now that do that.
You would need to evict a node. So you have to have enough resources to have an additional node on the side. So either you always have an additional node on the side, or you have a node that's in the cluster that just isn't being used and isn't required by requests or anything, so that you can evict it, take that node, reinstall an operating system on it so that it's clean, install Kubernetes.
Oh, now somebody needs to say in comments, did I
convert
stop screen?
You had a new template. Yeah. Or, okay. Sorry about that.
You're back.
Awesome. Yeah, don't know what happened there, or you add in a virtualization environment, you add a new template with the right version, you just clone the VM, add it to the cluster, and remove the old VM. Much quicker. You can upgrade clusters in minutes instead of hours or days.
Fair enough. Okay. EKS add-ons managed versus self-managed. And my answer is very simple. It depends on the add-on. I'm very much against... So let me put it this way, and I will not limit it to AWS, but in general. I'm very much against add-ons that are specific to the provider, hey, we have this add-on that is doing something that works only with us, nobody saw it before, and there is a bunch of well-known alternatives to it. Unless it's to the level that is really, actually, even that what I said is not true, right? Like cluster scaler, right? Use the add-on because the provider knows what it is. I'm just not 100% sure that you should be using add-on for let's say, observability.
The OpenTelemetry collector?
Huh?
OpenTelemetry collector and things like that, just to do a helm install, please. Don't use
Yeah, exactly. So I don't know. I don't have the answer without looking at the add-on, to be honest.
So I have a general answer here, which is if you are going to use an add-on, use a managed add-on. If you're not using a managed add-on, don't use an add-on. I don't see the value in self-managed add-ons. The second that I need to manage it myself, I would rather use what the community uses, which are typically Helm charts and things like that have more testing, that have more usage, that have wider capabilities typically than the add-ons do. If you want to get the benefit out of add-ons, which you should for certain things, those add-ons should be managed, and then you don't need to take care of it. But if I anyways need to manage something, I would rather manage what comes from the community than have to manage what specifically comes from, a distribution, let's say, of sorts.
See, while you were answering that, I realized that I probably misunderstood the question. I understood it, and I'm misinterpreting it here. Use the add-ons or self-manage it, whatever it is, yourself without add-ons. But if the question is self-managed add-ons, yeah, that doesn't make sense.
Which there are, right? There's managed add-ons and self-managed add-ons.
Yeah, no. You're right. I misunderstood the question. I thought kind of like use the add-ons or no. So there is a provider, which I'm not going to name, one of the smaller ones, that has a large number of add-ons. And behind the hood, they're all literally doing Helm install.
Right.
And makes zero sense.
Yeah.
Anyways.
Exactly.
But if your provider is guaranteeing, kind of like I'm supporting, I'm making sure that this runs, go for it.
Then use it. Right.
Okay, this is the question that I cannot answer because I'm obviously biased. Crossplane is my project. So whatever I say is going to be interpreted as being subjective. Scott, Go for it.
So, do you think Crossplane is more fruitful than Terraform? Today, no. Do I believe it has the potential to be more fruitful? The answer is yes. I'm not sure that I would say more fruitful. Also, I'll explain. I am a huge fanboy of Crossplane. I love Crossplane. I will say that Crossplane is just like Terraform in the sense that each of them defined a new methodology to work with in, the IT world. Terraform was the first real infrastructure as code tool that was not tied to a specific vendor, right? You had CloudFormation existed before, but it's the first one that was not tied to a vendor, right? That actually came and said, here is how you do infrastructure as code, desired state, awesome. Great job, Terraform. And they innovated in that area and made it huge. Crossplane is doing the same thing with control planes, right? With the continuous reconciliation, with the Kubernetes pattern, with the pattern of compositions, and creating these aggregated resources, and many things that Crossplane is doing. It is innovating in this area. We're already seeing tools being created inspired by it, like Crow from AWS, right? That are basically inspired by Crossplane. There's no chance that it wasn't. And so I think that Crossplane will have as much of an impact on the world as Terraform has. Terraform is a name that everyone knows in the IT world, and I think that Crossplane will be that same thing. What will be the adoption rate of it? I am very hopeful. Does it have as much impact today on the world as Terraform does? Absolutely not. It's not nearly as big of a project. It's not nearly as adopted. It's still the cool kids playing with it. I think the hype cycle is about over, though, and it's reaching that level of, stability that, we're starting to see more and more companies that are more, let's say, conservative, starting to use it as well. So I see huge potential. I think the next 2 years will be huge for Crossplane. It's not there where Terraform is, but it's having the same impact as Terraform did in its early years as well.
One thing I agree with most of what you said, but only if you look at Terraform against Crossplane in isolation. If we start looking at, let me change Crossplane to Cluster API. I'm just going to change to be something else.
Right.
If you look at them in isolation, you're right. Kind of, there is no such level of adoption yet, and so on and so forth, right? But if we look at them as part of, let's call it CNCF ecosystem, right? Then I think that the story, adoption is still lower, of course, because there are many years behind Terraform. But then the story changes, because then we're talking about something that works with everything else, assuming that you're Kubernetes fanboy, right? So you want
Exactly.
GitOps, here you go. You're used to collect metrics with Prometheus, there you go, right? Kind of logs. If you're in the Kubernetes ecosystem, then Cluster API, and I'm intentionally changing the project here, provide certain benefits that other projects outside Kubernetes don't. Not because they're better projects.
No question. Right. But again, that's the potential value that it has, not necessarily the, is it as fruitful? It is not nearly as fruitful today of a project. There are huge reasons to use it. And because of those reasons, it will become fruitful. But It just takes time.
Exactly. Okay. This is from Pavel. I have a question about job as DevOps. I have around 10 years of experience as backend developer, 3 years as DevOps, mainly AWS. I know AWS, Kubernetes, Helm, Terraform, GitLab, CI/CD, Python. There's more. I have 4 certificates, 3x AWS SysOps, DevOps developer, CKD. But lastly, I needed to search job around 4 months. How can I additionally increase my chance to find new job? I have 2 things there, 3. I'm not sure how much they apply to you, right? First is it takes time to get real world experience, and you know that you got it when you stop mentioning the certificates. And that simply takes time. That's outside your control, right? Where you work influences a lot the potential. So let's say, if I would get an offer, let's say that I'm just starting, I would accept offer at Red Hat for half of the salary than bigger salary somewhere else. Because that gives you the name or a company that through which you're more eligible for future employments, right? That matters a lot. And but that also might be outside your control, right? What is not outside of your control, that's open source. If you work in an unknown company and you don't have like 20 years of experience, contributing somewhere increases your value much more than people see or think.
Yeah. I think in general, if you wanted a specific, what you can do to increase your chances to find a new job, to tell you the complete truth, it's going to the conferences or the networking events and just meeting people and talking to them and, being involved in the community. Because if there's one thing that I've noticed is that, the DevOps world, especially in like the Kubernetes community in particular, are very much, let's call it nepotism, but in a good way. Right? It's all this friend knows this guy because they work together on this SIG in Kubernetes and they did this together. And the whole world works that way, but the Kubernetes ecosystem really is a family in a sense that, it's people that, I know him, and then you bring him to the company and then he helps you get a job at the company. There is a part in being out there, being in the community. Me and Victor are very similar in one thing. Both of us go to conferences a lot. Both of us speak at conferences a lot. Both of us barely ever have made it into a session that we are not giving at a conference. Because the most important thing at a conference is the hallway track. It's talking to people. It's meeting the community. And that's the way, I think.
Absolutely. Because when you get to that point, and that's what I meant without really explaining well when I said open source. I meant community as a large, including conferences, right? Because at one moment you get to the point that when you're looking for a job, you're not applying to the jobs anymore in wherever jobs are being posted. You then call your friends.
Exactly.
Basically, that's how you get the job, right? Because they know you and they're going to hire you rather than somebody who is on a paper better than you. But they don't know that that's really the truth, because on paper, everybody's good. There is nobody who doesn't know stuff on paper.
Right. They're going to see on Twitter or on Slack or whatever that you changed your status to, looking for, a new opportunity. And they're going to reach out to you and say, hey, man, like, do you want me to check if we have something internally? I'd love to work with you, like, at our company, right? Like, and it takes time to build that type of, influence, but it can happen.
Doesn't have to be, conferences can be cost prohibitive for many people. So,
right.
There is a lot you can do without investing money. There is a local meetup almost certainly in your area, kind of.
That's what, exactly. Do those. Go to the local KCD. Go to the local meetup group of platform engineering or CNCF or AWS or anything. Go to the local events. But
here's the important thing. Do not go to local events with a goal to find job. People don't like that at all. Kind of, if you appear on a meetup, and you have a face that I'm looking for a job, that will not produce any results. Go there, be active without trying to find a job. It will take time, but then jobs will find you.
Exactly.
Not immediately. So it doesn't solve your immediate problem. Here's one. I will not even try to answer this because I think that this is Scott's favorite question. What do you think about OpenShift? Are there enough benefits in an enterprise environment? And before you answer, I will answer it without OpenShift and say that there's a lot of benefits of having supported distribution of your system somewhere, which I think that Scott answered partly before. Kind of, don't go for your own, I know better than anybody else. I'm going to set it up with kubeadm. So from that perspective, my answer for OpenShift is huge, yes, but only putting it in the same basket as Tanzu and Rancher and other distributions.
Right.
But now I will let Scott answer it specifically for OpenShift.
So
I'm throwing you under the bus here, man.
Yeah, I'm trying to watch my language here because we are recorded and live. OpenShift has brought some amazing things into the world. It was the first, let's say, enterprise-ready Kubernetes-based solution on-premise, right? Like, there's no question about that, and what Red Hat have done in that area is amazing. I am not a fan of OpenShift myself for multiple reasons. I think that it reinforces bad practices instead of enforcing good practices. Having a clicky UI that gives me a form to create a deployment that goes and actually applies that to my cluster instead of pushing that up to Git and having Argo CD or Flux or some GitOps tool pull it down, basically is a great way to sell. It's a great way to get, the people to look at this and say, ooh, this is pretty, but it goes against best practices. And I have issues with tools that, make it easy to not do things right. And I think OpenShift does that too much. Also, OpenShift is not standard Kubernetes. If you notice, every application that exists out there, third-party application, has a Helm chart, and then they have a certified operator for that. Or they don't have the certified operator, but almost every Helm chart has a field of OpenShift, true or false, or distribution, and it's OpenShift or Kubernetes. And the reason is because there are differences in that there are routes. Well, they have Egress now, but they didn't for a while. They had routes, right, which was their own thing, which existed before Egress. Egress is inspired by what they did, but then the upstream went to Egress, and it took them so long to get there. There's an issue of that. I think they're the only distribution I know of that does not use Containerd. They use Cryo. Now, I'm not coming to say who is better. Cryo is more secure than Containerd. Fine. But the whole industry has come and said Containerd. So if everything is tested on Containerd, I would rather run with standards in the industry and not run with, proprietary, even if it is open source, right? I'm going to use Docker and not Podman, even though Podman is more secure, because the industry uses Docker. So I'm going to use Docker, and it's that simple, right? Like, in my mind. So OpenShift gives a great user experience. It is a magnificent tool at creating vendor lock-in, because the second that you use it, you don't move away. It's very hard to move away because of all the specifics of how they deal with security, how they deal with different things that make it You have to make your manifest work with OpenShift. I prefer vanilla Kubernetes. Be that, my favorites out there, which are Tanzu and Spectro Cloud, specifically, be it Rancher, be it, anything else, EKS Anywhere, Google Anthos. But those are all Kubernetes. They are not Kubernetes-based solutions. They are Kubernetes. OpenShift is a Kubernetes-based solution. It's also too heavy, has too many components.
Yeah, it's designed to begin with. I would say that if you're not a big enterprise, don't even think about it, right? It's overwhelming. And then we should start discussing if you are a big enterprise, whether it's a good thing or not. But the only thing that I will add is when you were talking about standards, right? I do agree on it in cases when non-standard things provide marginal improvements, right? We shouldn't always stick with standards, because if we stick with standards, we are back in mainframe, right?
Of course.
So, yeah, Cryo, why use Cryo? I mean, kind of somebody would need to give me a very good reason. But if I get a really good reason, then yes, I'm going to switch to it.
Exactly. But I'm saying that in the end, you're running the same Helm chart that you were going to run on Kubernetes. So exactly. What is your actual value that I'm getting from Cryo? And the answer is, in my mind, not that much once you add runtime protection, or once you add anything that actually secures your runtime, which anyways you should be doing even if you're an OpenShift. So add your runtime protection, and then who cares?
Okay, I think that we're at the top of the hour, a minute or two over. Unless I messed up this stream as I did previous, and YouTube deletes all the comments, I will collect those that are left, and we're going to answer them next week. And when I clicked stop streaming here, I'm going to stay online with Scott, and I'm going to tell him which microphone to buy. That's happening. Cheers, everybody.